Let's solve a system of linear equations in two variables by elimination. The first goal when solving a system by elimination is to write each equation in standard linear form. Just to remind ourselves, standard linear form is ax plus by equals c. So the x term and the y term need to be on the same side of the equal sign. In alphabetical order, x first, then y. Here is an example for us to work on. 3x equals 2y plus 2. 5x minus 5y minus 10 equals 0. To reach our first goal of writing these equations in standard linear form, we first need to subtract the 2y from both sides of the first equation. This puts the first equation in standard linear form. In the second equation, the x term and the y term are both in their correct spots, but the constant term, negative 10, should move to the right side of the equal sign. We can accomplish this by adding 10 to both sides. We have reached our first goal of writing the equations in standard linear form. Our second goal in solving by elimination is to create a zero pair among the x terms or the y terms of both equations. This means that either the two x terms or the two y terms have the same coefficient but are opposite in sign, one positive and one negative. For our example, we could create a zero pair with the x terms or the y terms. Let's work on the x terms. Since the coefficients 3 and 5 share no common factors, I'm going to multiply each term in the first equation by 5 to create the scaled equation 15x minus 10y equals 10. I'm now going to multiply each term in the second equation by negative 3. Negative because I want the coefficient on the second x term to be negative. This gives us the scaled equation negative 15x plus 15y equals negative 30. Notice that we have created a zero pair between our two x terms, 15x and negative 15x. Our third goal when solving by elimination is to add the two standard equations together. Because we created a zero pair between our x terms, these terms cancel, and our x variable disappears. The y terms add to give 5y, and the constant terms add to give negative 20 for the simplified equation 5y equals negative 20. We can easily solve for y by dividing both sides by 5. Y equals negative 4. Our final goal is to solve for x. Since we now know that y equals negative 4, we can substitute negative 4 for y in either of our standard linear equations. Choosing the first one, we see that 3x minus 2 times negative 4 equals 2, so 3x plus 8 equals 2. Subtracting 8 from both sides combines our constant terms to give the simplified equation 3x equals negative 6. We can easily solve for x by dividing both sides by 3. X equals negative 2. The coordinate pair then that makes both of our linear equations in the system true is negative 2, negative 4. Just to review, when solving a system of linear equations by elimination, first, write both equations in standard linear form. Second, multiply one or both equations by a scale factor to create a zero pair between the x or the y terms. Remember, a zero pair has the same number but opposite signs. Third, add the two standard linear equations together to solve for one variable. Solve for the second variable by substituting the solution of the first variable into one of the original equations.